Okay. We will move from having something moving at constant speed, constant velocity, and start adding forces. So we can log in and set up for a new trinket, a script, Python. Let's give it a name, force 1. Okay, so since things are going to be moving and changing speeds, we can set the range of the scene to be some good sized number. We can make it smaller later if we want. And we'll create an object so we can watch things happen. Call it ball, ball is sphere. Make the radius, say 0.2. And we'll work with a simulation of a ball that's thrown straight upwards. Ball.vel. Remember, ball is the name of the object. Vel, we are now creating an attribute of that object. Velocity is a vector. Zero, let's say 5 meters per second. Let's say 10 meters per second. 0 meters per second. So again, this is saying it has no motion in the x, no motion in the y, and it's moving at 10 meters per second in the z, in the y, no motion in the z. We'll give it a mass. Ball mass. Let's say 2 kilograms. Okay, anything else we need? That'll do for now. Well, I guess we should set our time step. So to say 0.03 seconds again. Okay, so we want the ball to move. So we want to do the calculations of momentum update and position update again and again and again and again. So make a blank line here, a couple blank lines. So remember, the calculations we want to do over and over and over again want to be indented. So start with time at 0, just because it's there. So one thing we want to make sure that gets recalculated every time is time. Time equals time plus dt, so time is ticking, and this is intended. It'll do this calculation over and over. We want to calculate the force. So if we're doing force of gravity, Fgrav equals, so it's calculated as the mass, which remember is named ball.mass, times, and it is a quantity that has direction. We'll say that y is up, so the direction is 0 in the x. The y direction, if plus is up, down is minus, and it's the mass times the number 9.8. And then the z will say is 0. So goes the force in newtons. Oops. So after calculating the force, we do a calculation that we didn't have to do before, and that calculation is the change of velocity. Velocity change, well, actually we're doing momentum. Momentum change is equal to, in the definition of it, the definition of force momentum, it's the force times the little bit of time that is passing. So the little bit of time that is passing times the force tells us how much the momentum changes by. Let's go back up here and also define momentum then. In fact, instead of defining, let's define momentum instead of the velocity. So I'll move the mass up here. And take the mass times velocity. So the new momentum, all dot mom, equal the old momentum, which is all dot mom, but it's on the right side, plus momentum change, mom, change. So that's momentum update. Then position update, all dot pause. Updates as, we take the old position, add to it the change of position. Let's break this down. So I'm actually making a new line, change of position. Pause, dot, change equals momentum divided by the mass times a little bit of time. So the position change can be added to the old position to give the new position. Okay, so those are lines. We update time, calculate the force, we update momentum, then we update position, and we want this to keep going. How long do we want to keep this going? Well, that's a good question. We didn't specify the initial position of the ball up here, so that means it will start at the origin. X equals 0, y equals z equals 0. So we could keep this going until y returns to 0, or tries to go below 0. So do this while, all dot pause the y piece of it. It's greater than or equal to 0. So when it tries to go below ground, we'll stop. Okay, save. So it doesn't want to save until I run it, so let's run it. Okay, that happened too fast. One thing that we did before that we haven't put in here was we put in a little pause, a pause of 0.03 seconds between frames. The more usual way of doing that is the first line inside of here is a rate function. So let's do rate, say 33. That would count 33 frames a second. Each frame is 0.03 seconds. went up and came back down, just like we expect. Okay, technical term. The set of lines that is repeated over and over and over again, that's called a loop. We're looping over these calculations. Okay, so that is what we need to do to add momentum update together with position update. So far we only have motion in one dimension. Motion in two dimensions, we have to consider something a little more carefully. And we'll add a couple more features in the next video.